So what if I told you that one of America's favorite sport fish is now at the very center of a high-stakes global battle between feeding the world and triggering an ecological disaster? Today, we are diving into the incredible and honestly pretty controversial story of the largemouth bass. This is a fish that's gone from a weekend hobby to a billion-dollar high-tech industry with some major consequences.
And just to give you a sense of the sheer scale we're talking about, look at this number. Almost 900,000 tons. That's how much largemouth bass a single country, China, produced in 2023 alone. And that number, it's not just big, it's a huge signal of an aquaculture explosion that has totally changed the game for this species.
So where did that massive number come from? Well, it's all thanks to a radical transformation. For decades, the largemouth bass was mostly just bred to restock ponds for fishermen. Fun, right? Well, now it's an industrial-scale meat production powerhouse, engineered from the ground up to feed a growing planet. Yeah, we're not talking about your weekend fishing trip anymore. We're talking about feeding millions.
So how in the world did this one fish become such a global phenomenon? I mean, an aquaculture superstar? Well, sure, its natural toughness made it a pretty good candidate for farming, but its rise to the top is really a story about one country's laser-focused ambition. Okay, take a look at this chart. It just says it all, right? The dominance is just staggering. In 2023, China was responsible for more than 99% of all largemouth bass produced in the world. That's practically a total monopoly, and it's all driven by huge government investment in technology and a strategic mission to lock down food security. The rest of the world? It's barely even a blip on the radar. Now, this kind of massive production isn't happening in some muddy pond out back. Nope. This is all thanks to a huge shift into precision biotechnology, where pretty much every single variable of a fish's life is measured, optimized, and completely controlled.
And the key piece of tech making it all happen is something called Recirculating Aquaculture Systems, or RAS for short. And you've got to forget the idea of a farm. Think of these more like high-tech indoor fish factories. They allow for absolutely insane stocking densities. We're talking over 60 kilograms per cubic meter, because they can perfectly control water quality, temperature, and oxygen 24/7.
But, with that much control comes a ton of complexity. The largemouth bass is a carnivore through and through, and its diet has to be absolutely perfect. As you can see, it needs a huge amount of protein. But here's the kicker, the really crucial part, it has a super low tolerance for carbohydrates. If they get more than 20%, it can cause serious liver damage. So just designing a food pellet that works and doesn't break the bank is a constant scientific battle.
So, okay, we've got this perfect, high-tech, super efficient protein source that could help feed the world. Sounds amazing, right? A huge win. Well, and this is a big well. There is a much darker side to this success story. A side that turns this amazing food source into a serious ecological threat.
You see, the very same things that make it a dream fish for aquaculture, how adaptable it is, its crazy appetite, how fast it grows, are the exact same things that make it an absolute nightmare when it gets out into the wild.
In this quote, it says everything. The International Union for Conservation of Nature, we're talking one of the top environmental authorities in the world. They don't pull any punches. They list the largemouth bass as one of the 100 most harmful invasive species on the entire planet. This isn't just some small issue. It's a full-blown, code-red emergency for biodiversity. When this apex predator escapes into a new lake or river, the damage is, well, it's catastrophic. It just outhunts and outcompetes everything else. And that kicks off what scientists call negative cascading effects. For instance, it eats up all the little fish that eat insects. So what happens? The insect populations explode, and that can damage local plants. The entire food web gets knocked sideways, and that often leads to huge economic losses for local fishermen. The threats aren't just external, though. Inside these high-density fish factories, the people running them are in a constant, invisible war. You see, when you pack that many animals that close together, you're basically rolling out the welcome mat for infectious diseases that can literally wipe out an entire farm overnight. Two viruses, in particular, are the stuff of nightmares for these farmers. There's the Rhabdovirus, which can just hide in the population, totally silent, until some kind of stress triggers it. But the real monster is the Micropterus salmoides Rhabdovirus, MSRV. It absolutely devastates young fish, with death rates that can shoot past 80%. And here's the truly terrifying part. Right now, there are no commercial vaccines, no effective drugs, nothing. Now, when we're talking bacterial infections, the toolbox is a little bigger, but it's shrinking fast. Some antibiotics, like fluorophenical, are still workhorses against the most common bugs. But then you look down at sulfonamides, and they're practically useless. The bacteria have just developed so much resistance. It's a constant arms race just to stay one step ahead.
And all of this brings us to the core conflict of this whole story: innovation versus invasion. Our own ingenuity has created both this incredible food source and a potential ecological time bomb. So the billion-dollar question is, can the very same science that got us into this mess be the thing that gets us out?
This timeline really shows you how fast the science is moving. Just a couple of years back, the main focus was just on population ecology, studying the fish out in the wild. Now, we're deep into gene sequencing and transcriptomics, which is basically like reading the fish's genetic playbook to see what it's doing. And looking ahead, the next frontier is subcellular immunology, learning how to manipulate the fish's own immune system at the cellular level. I mean, the research that's happening right now is just wild. Instead of just reacting to diseases, scientists are trying to get ahead of them completely. Think about it. What if you could design smart diets that basically act like preventative medicine? Or what if you could literally go into the cell and just block a virus from being able to copy itself? The end goal here is to build a genetically tougher bass from the ground up, one that's both super productive and totally biosecure.
And that leaves us right here with this one massive question. The largemouth bass is this powerful symbol of our ability to engineer nature to help ourselves. But it's also a serious reminder that nature plays by its own rules. So as we keep pushing the limits of technology to create the perfect fish, are we really solving the problem, or are we just getting better at managing a crisis we created ourselves? Can our technology ever really outrun the fundamental laws of ecology? It's a question worth thinking about.